Friends, welcome. I am Yashwardhan, an electronic enthusiastic and electronic engineer who likes to explain about the different electronic concepts and explain in detail about the electronic circuits. Today, as the part of the ongoing series where I will be discussing some of the important sums in electronics that is related to different topics in electronics, I have already explained two sums. If anyone has not seen those previous video, I will keep the link in the description below as well as at the top of the I button. Please watch that video first and then come and watch this video. Now, today I will be explaining about this sum. This sum I found a very interesting sum, and this type of sums are mostly expected in almost all the competitive exams like GATE or any kind of entrance exam that you take in order to get into any PG course in any college. So let's see the question. First, the question says that consider the length 8 sequence, that is there is a length 8 sequence which is defined for 0 to 8, that is it is defined for the values of n ranging from 0 to 8 and both are inclusive, and we are given the sequence as x of n is 1, 2, minus 3, 0, 1, minus 1, 4 and 2, and it is having a simple 8-point DFT. Now we need to evaluate the following values without computing the value of DFT. This is a very tricky, this is the logic here, because using DFT we can easily find this, but he said that we should not compute the whole DFT, we should evaluate what are these values, and this is a very simple sum also. Let us do this. So first let me write the solution. A bit, we need x of 0. So how we get? We know we are given x of n and we are given that it is a length 8 sequence. So we know that capital N is 8. So therefore we know that DFT of x of n, that is x of k, is given as sigma, sigma n small n varies from 0 to capital N minus 1 into x of n into e power minus j to pi k small n by capital N. This is the DFT formula, right? Now in the place of, now we need to get the value of x of 0. Replace k value with 0. So we get capital X of 0 is nothing but sigma n is equals to 0 to n minus 1, and we can replace capital N by 8 because it is as capital N is 8, we can replace it as 8 into x of n. You may ask me what happened to this term. Now whenever you are substituting k is equals 0, you substitute in this place, you become minus j is 0, which is nothing but e power minus 0. Anything to the power of 0 becomes 1. So we can, to further clarity, write it as into 1. So this is nothing but summation of the whole sequence, right? Which is nothing but k is equals 0 to 7 x of n, which is nothing but just summation of all these values. Let us sum them. That's 2 minus 3 plus 0 plus 1 minus 1 plus 4 plus 2. If you observe, all these terms up to this term get cancelled because 1 plus 2, 3, 3 minus 3, 0, 0 plus 0, 0, 1, 0 plus 1, 1, 1 minus 1, 0. Now plus 4 plus 2, we have 6. Therefore, I can write my capital X of 0 is 6. So without computing the actual DFT only, we have found the capital X of 0. Now let us find the B bit, which is x of 4. Simple. In order to get x of 4, in place of k, they replace it as 4. Replace k value with 4. We have capital N is equals to 0 to capital N minus 1, which is 8 minus 1, 7, into your x of n. Now you replace k value with, let us consider this equation 1. In equation 1, replace k value with 4. We have 4 2 is 8. 8 by capital N is also 8. 8 gets cancelled. You are left with e power minus j pi n, right? But if you observe, e power minus j pi is nothing but minus 1. So we can write it as 0 to 7 x of n into minus 1 power n. Why, you may ask me? Because whenever you have, since e power j theta, we know it is as cos theta plus j sin theta. Put theta is equals to minus pi. If you put, we get cos minus pi plus j sin minus pi. If you know cos minus 180 degrees is minus 1 plus j sin 180 degrees is 0. So we will be left with e power minus j pi is nothing but minus 1. This is the reason, as it is whole to the power of n, so it is like this. Now let us evaluate this. So put x is equal, for x of 0, we have x of 0 into e minus 1 power 0, which is 1, plus 2 into minus 1 plus minus 3 into 1. As this is a minus 1, we can easily write alternate plus and minus. You can evaluate and you can evaluate this. Just replace small n value with this value, and it's 0, 1, 2, 3, 4, 5, 6, 7. So for x is equal, for x of 0 into e power minus 1 power 0, we have 1 into 1 plus x of 1 is 2 into e power minus 1 whole to the power of 1, 2 into minus 1. Similarly, x of 2 value is minus 3 and minus 1 square is 1. Similarly, let me write the other value, which is 0 into minus 1 plus 1 into 1 plus minus 1 into minus 1 plus 4 into minus 1 power 6, which is 1, plus 2 into minus 1 power 7, which is minus 1. So yeah, so let's do it here. This is continued here. So which will get 1 minus 2 minus 3 plus 0 plus 1 plus 1 minus 1 into minus 1 plus 4 minus 2. Now if you observe this, if you evaluate this very carefully, you have 3 ones. So 1 plus 1 plus 1 is 3, 3 minus 3 is 0. Similarly, 4 minus 2 is 2, 2 minus 2 is 0, 0 plus 0, we have 0. So therefore I can write my capital X of 4 is 0. So I got the second value also without computing. Now let us move on to the C value. Okay. So this is the A bit, this is the second bit, and this is the third bit. Like in competitive exam, you may not be given to find all the 5 values, or if you are given, you may get it as 5 bits. That is, in each bit you can get one of the equation, or you can get any one of the equation. Now finding the third equation, we need this. We know that from the equation 1, this is the DFT. What will be inverse form, inverse IDFT x of n? You need from x of k, which is nothing but 1 by n sigma n is equals to 0 to 0 to capital N minus 1 into your x of k e power j 2 pi k small n by capital N. This is the IDFT formula, right? Correct? Yeah. Now replace small n by 0 with 0. Then you have small x of 0 is nothing but 1 by capital N is 8 sigma k is equals to 8 minus 1 7 into x of k. Now put small n is equals to 0. It becomes e power 0, which is 1. So this. Therefore n is sigma k is equals to 0 to 7 x of k, which is nothing but, if I transpose this, 8 into x of 0. That is 8 into, what is my x of 0? 1. So I have 8. Therefore I can write sigma k is equals to 0 to 7 x of k is nothing but 8. That's it. Third bit is also evaluated. I hope friends you have understood the first three solutions. Now let us do the D bit. D bit is a little bit tricky, but it's also useful. Now we know that if x of n has its DFT as x of k, then if we are using the circular shift method, then DFT of, due to the circular shifting property, we have DFT of x of n small n minus capital N whole to the power of n will have the DFT as e power minus j 2 pi k small l by capital N into your x of k. So DFT of this term is this, right? So what will be IDFT? That is small x of n n minus L, I need this value, which will become nothing but 1 by n sigma k is equals to 0 to capital N minus 1 e power minus j 2 pi k smaller by capital N into my x of k, right? But we require it is in this form. So we know that capital N is 8. So we need get 3 by 4. So let us replace L by 3. So we have x of n minus 3 to the circle 8 terms I have. It is nothing but 1 by 8 sigma k is equals to 0 to 7 e power. Let me, in place of L we have written as 3 to 6 by 8, which is nothing but 3 by 4, right? 3 pi k by 4 into x of k. Okay, now we need to evaluate this. Therefore I need sigma k is equals to 0 to 7 e power minus j 3 pi k by 4 into x of k value I need, which is nothing but 8 into your x of n minus 3 to the power of 8, right? Right? That's what we require, right? Now we need to put n is equals to 0, because by simple logic, because if we keep any other value, you cannot evaluate this. It becomes an infinite value. For example, let us put, if I put as 1, it is 1 minus 2, minus 2, 8 minus 2, 6, which is x of 6, which will be a wrong. You will not get the value correctly. So n value should be 0. So first n value you put, we have 8 into x of minus 3 to the power of 8, right? I taken small n is equals to 0. Now this is the value. Now you can evaluate this by using the circular shifting property, which is capital N minus n is 0 plus minus 3. We have 8 minus 3, which is 5. So 8 into x of 5, which is 8 into, what is x of 5 I am having? 0, 1, 2, 3, 4, 5. So minus 8. That's the answer, right? So now I hope you have understood the first 4 bits. Now let us see the last bit. If you carefully observe, the last bit is very easy, and it is always already in the form of one notable form. Anyone is guessing? Yeah, it is Passwell's theorem. By Passwell's theorem, we know that it is nothing but 1 by n sigma k is equals to 0 to n minus 1 into mod x of k whole square is nothing but sigma n is equals to 0 to capital N minus 1 x of n mod x of n whole square. This is the Passwell's theorem. Well, theorem, and it's a very famous theorem. Replace all the values. We require sigma k is equals to 0 to capital N minus 1 is 7 into mod x of k whole square. Transpose this capital N to here, which is capital N is 8. So let me replace it as 8, and sigma, this is n is equals to 0 to 7 mod x of n whole square. We require, this is the value we require, this is the answer. So 8 into, let us evaluate this. This is nothing but 1 plus 4 plus 3 minus 9 plus 0 plus 1 plus 1 plus 16 plus 4. This is nothing but 20, 23, 27, 27 plus 9, which is 36, 36 into 8, 288. So we have 288. That's the answer. So now I hope friends you have gotten a good clarity about how to solve this kind of problem. If you have any doubt at any point, please stop the pause the video, watch that again, go back a little bit, again watch that part until you get clarity. If you are still not getting the answer, you can comment that down below and I will clarify your doubt in the comment section below. Also, if anyone is in the final year and they are working on any project and have any doubts on how to work with Arduino or any other Arduino in HFSS, you can contact me in my mail ID and I will deal with you. I will deal accordingly. So I hope friends you like my explanation and have gained some knowledge. Thank you. If you like my explanation and want to see more such video, please like this video and share it with your friends, and do subscribe my channel. And for the people who have already subscribed my channel, a hearty thanks for supporting the channel. And for the people who have newly found this channel and like to watch such content, consider subscribing the channel. It helps me, it gives me the motivation to work on more videos. And also like the video. Thank you friends. Thanks for watching friends, and I will meet you again in a new video with a new concept. Until then, stay tuned to the channel to learn something new.